All right, so this will be the last class for this week. Again, I'm only uploading 2 videos because this is a fairly complicated concept. So practice a lot with graphing, which was the previous class. This class, we're gonna um, work with absolute value equations, which we've already done, but this is part two, which means that now we're gonna be working with slightly more complicated algebraic equations. Okay, so instead of linear functions, you'll see some quadratics in here. And that's basically the key difference, and it will make things slightly more challenging. Okay, so hopefully this is not going to be too long. Just remember that you do have a test on um, Friday. Okay, so there will be a test on Friday. I will be holding office hours on Thursdays, so just make sure you're using Wednesday. I know it's a free day for you, but use that wisely to catch up and get ready for the test. Okay. Now for the starter question, okay, this is going to be very relevant in a moment, but I'm just going to ask you to figure out when is this function positive and when is it negative. Okay, so another way of stating positive and negative is this way. Okay, so if I put this inequality, x squared minus 3x greater than or equal to 0, this just means when is my function positive. Okay, and this was given to you as a test question on the previous test, and some of you are confused. Okay, so this is another way of saying when is this function basically positive. Okay, and for negative, it's essentially the same thing, right? Negative would just be um, less than or equal to 0. So this is negative. Okay, so whenever you have an inequality, right, um, it's difficult to solve an inequality, especially if it deals with a quadratic. The best way to answer this question is to solve this question first. When is x squared minus 3x equals to 0? Okay, so before we can tackle the inequality, why don't we figure out when is it equal to 0? Because remember, 0 is like a threshold, right? It separates the positive from the negative. Once you have your zeros, you can graph the function and then go from there, or use the number line. Okay, so there's many ways of doing it. So I am just going to erase the stuff on top just to make some room for myself. But basically, just remember that there's many ways of wording a question in mathematics. Okay, positive basically means this, and negative means that. Okay, just kind of like remember that going forward. So, not a difficult question because we did this at the very beginning of the year, and then we did this in the previous unit. So let's work with a slightly easier question first, which is to solve this equality. Okay, so again, when you have a question like this, um, try factoring. Okay, because I don't have 3 terms, I only have 2. I don't have to use the fancy product sum method. I can just do simple factoring. Okay, so in this case, if I factor x, then I'm going to have x minus 3. And now you have a product equals to 0. Okay, the only way that a product is equal to 0 is if one of the terms is 0, right? So remember, I gave you this example. Let's call this a, let's call this b. So a times b can only be 0 either if a is equal to 0 or b is equal to 0, right? So using that logic, we can conclude that either x is equal to 0, right? Either this is equal to 0, so either x is equal to 0, or x minus 3 is equal to 0. So x minus 3 is, let me just write this a little nicer. So x minus 3 is equal to 0, which means that x is equal to 3, okay? So these are the two x values that make your function 0, okay? Now, to answer this question, positive and negative. I mean, the best approach would be to just simply graph it, right? So I'm going to show you a couple of methods, I guess. Graphing it, again, this is just a sketch, okay? So you don't need to scale anything, right? You know that your function is 0 at 0, and your function has a 0 value at 3. And because, this is your function over here, right? Let me just um, put a box around it. And obviously your a value is equals to 1. So it opens upwards, and basically this is what the function looks like. Okay, so the p-value will be in between, right? So it's essentially the average of these two values. So the p-value is 1.5, but let's not worry about that because it's not relevant. Okay, so my function is positive when it's above the x-axis, right? So my function is positive, oops, let me just draw this a little nicer. So my function is positive here, and it's positive here. But again, I have to give those answers in terms of my x values, okay? So if you want, why don't we put 0, right? X value here is 0, x value here is 3. So positive, right? My function is positive if x is less than 0, right? So this stuff over here, x has to be less than 0. Maybe let me use a different color, right? So why don't I do this? So positive when x is less than 0, right? So it's positive here, and these x value make your functions positive. And it's positive here as well, and that means your x value has to be greater than 3, right? So when x is less than 0 or when x is greater than 3. Negative is in between, right? So your function is negative over here. So maybe let me use a different color for negative. Negative is here, your function is negative here, but for which x values is your function negative? Well, for these x values, right? So x has to be between 0 and 3. And, because it's up to you, right? You could put an equal sign underneath. So why don't we do that? Because I'm using shaded circles, right? So that means I'm including the value. So here it doesn't really matter, right? So for positive and negative, you can include the zeros. But sometimes they use the word strictly positive, strictly negative. In that case, you don't have to. But in this case, we could. Okay, so it doesn't really matter either way. It's going to be right. Okay. Now the reason why we're doing all this is because we're gonna have to solve an absolute value with a quadratic term. Another way of doing this, guys, is to just use the number line. Okay, so um, remember the number line technique that I showed you. So if you want, I'm just gonna add an extra page. If you don't want to draw the graph, right? So give me 1 second. So basically, all you have to do is draw a number line, right? Put your zeros. So at 0, my function is 0, and at 3, it is 0, right? And basically, this is your function, f of x or y if you want. Y is equal to, I'm using y because that's how the question was posed, right? So this is what the initial question was asking. So I'm just going to be consistent with that. So what is it? X squared minus, so x squared minus 3x, and then when we factored this, we got x 3 minus x, right? And then now it's just a question of picking values, right? So if you pick a number less than 0, let's say negative 100, then this is negative, and 3 minus minus 100 will be positive. So positive times negative will is it sorry, it should be x minus 3, my bad. This is x minus 3. Okay, so now let's do this one more time. Pick a negative number, right? So anything less than 0, negative 100, this would be negative. Negative 100 minus 3 is also going to be negative. So negative and negative will make this positive, right? And if you pick a number between 0 and 3, let's just say 1. So this is positive, but 1 minus 3 will be negative 2, which is negative. So positive, negative will make this negative. And then finally, if you pick a big number, so let's say 100, right? Positive 100. So this would be positive. 100 minus 3 will also be positive. So positive times positive will be positive. Okay, so if you like the number line better, you can do that. Or if you want, you can just draw the graph and figure it out by looking at the picture, however you want to do it. I am going to draw the graph because I think some students are comfortable with that, right? It doesn't really matter. There's many ways of doing it, like I said. This is probably the fastest way. So anyway, so now let's go back to, so this is the answer to the question if you want, okay? And you can get this answer either by looking at the number line over here or by looking at the graph. Both of them will give you the same answer, okay? And now the question. So solve an absolute value question involving a quadratic expression. So you see the problem with this question, the reason why I never showed this to you previously is because now what you have inside your what you have inside your absolute value is a quadratic function, okay? But we're going to treat it the same way. So absolute value of x squared minus 3x, right, will equals to the same thing, which is x. Yeah, you know what? I'm just going to make some room for myself. So x squared minus absolute value of x squared minus 3x is equals to the same thing. So it doesn't change, right? As long as whatever I have inside is positive. So as long as x squared minus 3x is greater than or equals to 0. Okay, so I'm just using the definition, right? Remember that you don't do anything to the stuff that's on the inside if it's already positive, because if it's already positive, then it stays the same, right? That's what the absolute value does. So for example, absolute value of 5 will be 5. Doesn't change because it's already positive, okay? Now, see, the tricky part is, when is x squared minus 3x positive? And we just did that in the starter question, okay? So x squared minus 3x is positive when, so it's positive when x is less than or equals to 0 or greater than or equals to 3, okay? So that's when it's positive. So what you're gonna do is you're gonna say or, right? This when x is, what was it, less than or equals to 0? Yeah, okay. When x is less than or equals to 0, comma, x is greater than or equals to 3, okay? So this is equivalent to that, okay? Same thing. We did that in the starter question. Now, I'm gonna have to multiply the stuff on the inside by a negative number, by -1 actually, right? To make it positive, right? So again, go back to the definition of absolute value. So if you have -3 on the inside, right? The absolute value of -3 is 3, but how do you get 3? You have to multiply this -3, right, by -1, and then, -3 times -1 becomes 3. Okay, so we're going to do the same thing. So the stuff on the inside, if it's negative, right, if x squared minus 3x happens to be less than 0, negative, then I'm going to have to multiply this by -1 to make it positive, okay? But x squared minus 3x is less than 0. See, I'm not adding an equal sign because that's how the definition of the absolute value works, right? This one has an equal sign, this one doesn't. So my function is negative, right? If x is between 0 and 3. And in this case, I am not going to put the, so basically, or when x is less than 3, greater than 0. Okay, so where is this coming from? It's just coming from your starter question from here, okay? And I'm not putting the equal sign underneath. So what do I mean by that? I'm not putting the equal sign underneath over here in this case. Okay, I'm not. Oops. I'm not putting the equal sign underneath over here in either case. Why? Because of the fact that this is strictly less than 0, okay? And that's how the definition of the absolute value works. So now, if there was an equal sign over here, then I would have added the equal sign here and here, because then it means that, it's negative, but it could also be 0, right? But when it comes to absolute value, remember, only the top guy has this equality. The bottom, see, this is, now you have your piecewise function, right? So this guy will never have an equality underneath. Now, it's not that big of a deal, but like I'm just pointing it out. So I guess don't include that equal sign underneath, okay? Because it's not included in the definition, okay? And that's basically it, okay? And now you have your two cases. Okay, so your first case, case 1, right, is when x is less than or equals to 0, or when x is greater than or equals to 3. So we're talking about this case. If that's the case, then absolute value of x squared minus 3x is equals to 2 can be rewritten as this. Okay, so I'm going to drop my absolute value, and then you have this, right? And then how to solve a quadratic? Some of you are still struggling with, remember, the best way to solve a quadratic is to make it equals to 0. Okay, so again, just, get rid of the 2. So just do minus 2, right? This will disappear. So you get x squared minus 3x minus 2 is equals to 0. And product sum, I'm assuming it's not going to work here. Okay, so two numbers that multiply to negative 2 and add up to negative 3. I don't think that's possible, or is it? Yeah, it's not, okay? Because to get negative 2, there's only one possibility, right? One of the numbers has to be negative, and I'm not going to get minus 3, okay, if I add them up. The only way that I can get minus 3 is if both of them are negative. Okay, then I get minus 3. But if both of them are negative, then I'm going to get plus 2 over here. Okay, so this is not factorable. Okay, so again, try product sum. In this case, I don't think it's going to work. So in that case, you'll have to use your famous quadratic formula. Okay, so x will just equals to minus b plus and minus b squared minus 4ac divide by 2a. So you're going to have 2x values, right? So why don't I add an extra page? Okay, and I'm not going to work this out, but basically I'm going to ask you to do that. So a is equals to 1, right? Remember, compare this to ax squared plus bx plus c. So a is equals to 1, b is equals to minus 3, c is equals to minus 2. And when you work this out, I'm going to use my calculator. So x1, so my first solution. Remember, quadratic functions tend to have two solutions, right? Just give me 1 second. So we have equation 3, 9x. So a is 1, b is negative 3, c is negative 2. When you work this out, x1 is equals to 3 square root of 7 divided by 2. Okay, I'm just going to see what the decimal value is, because remember, so it's roughly 3.56. Okay, there's a reason why I'm changing this to a decimal value, and I'll mention that a little later. So x2 is essentially the same thing with a minus sign, right? 17 divided by 2, which will equals to minus 0.56. Okay, now remember, x either has to be greater than 3 or it has to be less than 0. Okay, you have to check if these values are within your domain. Okay, so is 3.56 greater than or equals to 3? Yes, it is. Okay, so what I'm gonna do is I'm gonna accept this, and it's minus 0.56 within your domain. So minus 0.56 is obviously not greater than or equals to 3, but there's, it has to be one or the other, right? But even though it doesn't respect this condition, it's fine. It's at least respecting this one, right? So minus 0.56 is less than 0. So I'm going to have to accept it, okay? So I'm going to accept this, and I'm also going to accept this, 3.56. So both of them are valid solutions, okay? And if you don't believe me, you can plug these values into the original equation, and you will see that they will give you a number very close to 2, because remember, these are just approximations, right? This is not exactly 3.56. So you're going to get like 1.99 or something like that. Okay, so work that out to convince yourself. I am not going to do that because it will just take too long. Now, case 2. Okay, case 2 is when x is between 0 and 3. Okay, so now case 2, x has to be between 0 and 3. Cannot equals to 0, cannot equals to 3. Okay, has to be in between. Okay, so slightly greater than 0, but slightly less than 3. If that is the case, then absolute value of x squared minus 3x is equals to 2, right? Because this is the case where my, absolute value is negative, right? So I'm going to have to drop the absolute value. But because it's negative, right, you have to attach this negative sign. And where is this coming from? It's coming from here, okay? From here. So it's if x is between 0 and 3, I'm going to replace my absolute value by this, okay? So kind of like what we did before, but now we're, making it a little bit more complicated. Okay, so this is equals to 2. And then if you want to distribute the -1, right, so multiply by -1. So this becomes minus x squared plus 3x is equals to 2. And then just make everything equals to 0. Okay, so again, I don't like to have negative a value, the coefficient. I don't like to have the negative, so I'm actually gonna move these two to the other side. Okay, many ways of doing it, right? You can just move it over, flip the sign, or you could just do plus x squared and minus 3x. Okay, so plus x squared minus 3x, and this disappears. Okay, and then so this will just become 0. Okay, but just be very careful when you're writing this. Always write this in the form ax squared plus bx plus c, so that you're not confusing yourself. Okay, so I'm gonna rewrite this as x squared minus 3x plus 2 is equals to 0. Okay, in this form. Why in this form? Because now it's really easy for me to identify what a is, what b is, and what c is. Okay, so in this case, a is equals to 1, b is equals to minus 3, and c is equals to 2. Okay, because if it's written in this form, then some of you might say that, oh, this is a, this is b, and this is c. No, that doesn't work like that, right? A is the coefficient of x squared, b is the coefficient of x, and c is your constant term. Okay, so one way to not confuse yourself is to write it the way I did, this way. Okay, and honestly, it doesn't matter, right? If you moved the 2 over to the other side, which would have been slightly easier, it's just your a value would have been negative. Doesn't matter how you do it. Okay, so yeah, so again, if it with this, because you won't have any negatives, I think it would be slightly easier for you, but it doesn't matter. Okay, so if you chose to at this stage, right, I had minus x squared plus 3x is equals to 2. I'm talking about this stage over here. If you chose to do minus 2 to get minus x squared plus 3x minus 2 is equals to 0, this would also work. Okay, but your a would be -1, B would be 3, and C would be -2. It's gonna work either way, okay? Because if I multiply this equation by -1 on both sides, then I'm gonna get this back, okay? So it's just equivalent. So it doesn't matter how you do it, okay? Now what I'm gonna do is I'm just gonna add an extra page again. Sorry. And how would you solve this? Again, product sum would not work, or no, in this case I think it would. Okay, in this case product sum would actually work. So I'm going to use product sum instead of the quadratic formula, because I'm looking for two numbers that multiply to 2 and that add up to -3. So this one's possible, right? -1 times -2 is 2, and -1 plus -2 is -3. Right? So, and again, it's the product sum really works. You can use the shortcut if the coefficient is 1. Okay, so I think I did a good thing by doing it the way I did. So I'm gonna use the shortcut, right? I'm just gonna put x minus 1, x minus 2, right? The -1 is coming from here, minus is coming from here, is equals to 0. So now I have two solutions, right? Either x minus 1 is equals to 0. It's going to do that, right? And then, or right, either this is equals to 0 because you have a product, or this is equals to 0, or x minus 2 is equals to 0. And then just solve for x, right? So that means x is equals to 1, or well, I mean, this is your or x is equals to 2. Again, once you find your solution, go back to um, the definition, okay? And see if those solutions are within, not the definition, I mean the domain. Look at the domain and see if those values are within your domain. So, 1 is greater than 0, and 2 is less than 3. Okay, so it seems like both of them are within my domain, so I'm going to have to accept both of them, okay? And there you go. And so that means my solution will be there's actually 4 possible x values that would satisfy this equation, right? So x will either have to be, so let's just rank them in increasing order. So there's okay, so there's 3 minus square root of 17 divide by, what is it, 2? Divide by 2, so that's the smallest one. So this is negative, and then there's 1, and then 2. And then finally, you have 3 plus square root of 17 divided by 2. Okay, so there's 4 solutions, which seems kind of weird to me. But I guess it is true. Okay, because 1 does work if you plug it in. And let me see, 2, does that work as well? 2, if you substitute 2 in, 2 squared is 4. Yeah, 2 would also work. And now let me check if 3.56 works, because I am usually there's like 3 solutions, but you could have 4, I guess. So what was it? 356. So 356 squared minus 3 times 356. That gives me 1.999. Yeah, so 356 does work. And minus 0.56. So minus 0.56 squared minus 3 times minus 0.56. Yeah, that also works. Okay. So there are 4 solutions. What you could also do is to convince yourself that there are 4 solutions. You could graph this. Okay. So and I think I'm going to do that. Sorry. I really need to observe that there are 4 solutions. So why don't we graph this? So we have x squared minus 3x. So let's quickly graph this. We have math and then absolute value of x. Where is the squared term? So x squared minus 3x, and the next one is 2. As you can see, right, there are 4 solutions, guys, okay, because the black function is touching the blue function at 4 different locations, okay? So 1 is negative, which is my 0.56, right? So as you can see, this is very close to 0.56. The second one is 1, right? It happens exactly at 1, and then at 2, and then finally at 3 like greater than 3.5, and then we found the value to be 3.56. Okay, so I think the maximum number of solutions that you can have when it comes to a quadratic, an absolute value of a quadratic, and a constant function is 4. Okay. Um, okay. So there you go. Okay. So the algebra does not lie. So we have 4 solutions here. Okay. So these are your 4 solutions. And how did I know that? It makes sense. Every time I found a solution, I always checked if it's within my domain. Okay. And in each case, it was. It was within my domain, so I couldn't really reject any of those, which is a rare case, okay? Anyway, so for the second question, I'm gonna ask you to do this one. Now, this one only has three, and the textbook will show you a step-by-step solution if you're confused. Okay, so please do this. Okay, so this is a higher level question. Okay, so this is as difficult as it's gonna get. Now the next question is slightly easier because even though we're gonna have to solve a quadratic function, right? We have a linear function inside the absolute value, so finding the two cases, the positive and negative are not going to be too challenging. Okay, so basically what we have to do is we have x minus 5. We're going to have to split this into two cases, right? So it remains the same. It remains x minus 5. If x minus 5 is positive, right, greater than or equal to 0, which is the same as saying if x is greater than or equals to 5. But if it's negative, then we have to multiply this by minus 1, right? So rewrite the same thing and then multiply it by a minus 1. And this is, you have to do this if the stuff on the inside happens to be negative. Okay, so x minus 5 is less than 0, which is the same as saying x is less than 5. Okay, so finding out this stuff over here, not that difficult when it's a linear function. But when it's a quadratic, then you have to, find the zeros first and then look at the graph to guide you or use the number line. Okay, but if it's a linear function, it's super easy to go from here to here. Okay, so this is a very easy question to answer. When is x minus 5 greater than 0? But this is a much difficult question to answer, this one. When is x squared minus 3x greater than or equals to 0? Okay, this is difficult because it's a quadratic, so you'll have to like graph this or use a number line. Okay, so this one isn't too bad. Okay, so there you go. Okay, so case one is when x is greater than or equals to 5. So if that's the case, then absolute value of x minus 5 equals to x squared minus 8x plus 15 will just equals to x minus 5. It's going to drop the absolute value. Why? Because x is greater than 5. So I can just replace it. I can replace this absolute value by that, right? So kind of like what you did last week, okay? And then now you have x squared minus 8x plus 15. Again, I like to keep my coefficient positive, so I'm actually going to remove these guys. So minus x plus 5, minus x plus 5, okay? So they will disappear, and you're going to have 0 is equals to x squared minus 9x plus 20, okay? So this might be solvable, right? Two numbers that multiply to 20 and add up to 9. So 4 and 5, both of them negative. Yeah. So this, right, again, you can do the product sum on the side if you want. Two numbers that multiply to 20 and add up to minus 9. So it's going to be minus 4 times 5, right? Minus 4 plus 5 is minus 9. So it does work, okay? So why don't we do that? So x minus 4, x minus 5, right? If this is the case, then again, you can break this into two cases. Either this is equal to 0 or that is equal to 0. And if you do that, then your solution will be, so let's add another page. Your solution is going to be x is equals to 4 or x is equals to 5. But now the question is, which one is within your domain, okay? So I will have to reject this one because my domain is greater than or equals to 5, so this one. So there's only one solution. Now let's go to case 2. Case 2 is when x is less than 5. And let's do this one more time. So if that is the case, then x minus 5, right, the initial question, the absolute value of x minus 5 is equals to x squared minus 8x plus 15. I am going to replace this absolute value by this guy over here because x is less than 5, okay? So very similar to what we did in the previous class. So this, I'm going to replace this with, give me 1 second. Okay, what was this? Plus 15, I think, right? Minus x squared. Yeah, plus 15, sorry. Anyway, so I'm going to replace this by minus x minus 5 is equals to x squared minus 8x plus 15. So distribute the minus 1, right? So minus x plus 5 is equals to x squared minus 8x plus 15. And then do plus x minus 5 plus x minus 5. And then this will just disappear. So you're going to have 0 is equals to x squared minus 7x plus 10. Oh, and this one will also work, right? I think this is factorable, right? So this would just be x minus 2 and then x minus 5, because minus 5 times minus 2 times minus 5 is 10, right? And then minus 2 plus minus 5 is minus 7. Okay, so two numbers that multiply to, right, 10 and add up to minus 7. So this one does work. So now so again, right, so if this is the case, then either this is equals to 0 or that is equals to 0, which means that either x is equals to 2 or x is equals to 5. Okay, so I'm skipping the steps over here because I went over this in the previous question. I don't want to spend too much time on this stuff that should be fairly straightforward by now, okay? So which one will I accept and which one will I reject? Is 2 less than 5? Yes, it is. Is 5 less than 5? Okay, it's strictly less than. There's no equal sign. Okay, so yes, it is. Okay, so I'm going to have to reject this. Sorry, no, it's not. That's why I'm rejecting. So this one, yes. This one, no. Okay. So my solution, my final solution is, if I put everything together, so x, there's going to be two solutions here. So x is equals to, let's just put them in increasing order. 5 for that one. So x is either equals to 2 or x is equals to 5. Okay, so these are the two solutions. Again, to convince yourself that this is the right solution, you can graph this. So why don't we do that? Okay, so x minus 5, x squared minus 8x plus 15. So give me 1 second. Clear. So math absolute value of x minus 5, and the other one was x squared minus 8x. Oops, this is not minus 8x plus 15, if I remember correctly. And there you go. Okay, as you can see, your solution is at 5, right? So this is 5. This one happens at the point 5. And the other one is up here, which happens at your x value is very close to 3, or is it, hold on, 2, I think, right? Yeah, 2 and 5. And I think that's what we got, okay? So 2 and 5, there you go, okay? So the algebra doesn't lie. I know that the graph looks very complicated. Okay, I haven't shown you how to graph a quadratic function. Actually, not this. Okay, so the graph looks very complicated over here because I haven't shown you how to. Well, I mean, in this case, you could graph, but the other one would have been very complicated. Okay, so the previous graphing, where you had 4 solutions, like this one, when I graphed it, right? Um, This one over here looked very scary. Don't worry about it, okay? Because you don't need to graph. You just need to be good at algebra, and algebra will tell you what the solutions are, okay? So don't worry about graphing any of these because they're complicated, okay? But if you do your algebra correctly, then you will get the right answer, okay? So why don't you try doing this one? Very similar to what I did. And again, you're gonna have two solutions, and these are your two solutions, okay? So try that out. And for homework, I'm gonna ask you to just do um, question 6 on page 389. Um, try doing all the questions, okay? So because it's a fairly complicated concept. So sorry for the long video again. I just had to go in detail and I had to show you the solutions using my graphing calculator. Remember, you guys have access to that, so please use that. But I'm only going to be posting 2 videos this week. So yeah, so Wednesday will be a free day. Um, and hopefully you can catch up and get ready for your test on Friday. Okay, so thank you so much for watching my video. You guys have an awesome day. Okay, take care. Bye.